Good morning, madam. I'm Naavind Balan from RY31, or they call as UR65220002. My metric card number is 2112911019. Okay, today I'm going to present about the control and uncontrollable half wave rectifier. So these are the procedure, and then I already find the input, output for the resistor load, inductor output for the inductance loads, and then the inductance output inductive load with the freewheeling diode. The result for the resistive load is 5.9913 volt, and then inductive load is 5.9378 volt, and then inductive load for freewheeling diode is 5.946. Okay, these are the discussion. Compare the peak voltage between the input and the output for the resistor load. The output voltage for the resistor load is low than the input voltage. Explain the effect of the inductive load. So these are the self-inducts EMF rise and fall in a perfect synchronized with the supply voltage, and the inductive load transfer the electrical energy and the magnetic energy with the then used to power mechanical device like an electrical motor. And then explain the effect of freewheeling diode of inductive. So a freewheeling diode is a principal function to allow the energy stored in the inductor to keep flowing by the supplying a short circuit line. And then the compare between the particle and theoretical result compare are the to the practical and the theoretical result by theoretical is greater than the practical value. The conclude of your finding is the observe that when the diode is open circuit, both the output induct voltage are the same, starting that the inductor current is zero at the moment. The voltage rise resistor is zero when the voltage applied to the diode is reversed, no current pass through the inductor and the diode is shut off. Okay, then that's all for this one. And the design, the input voltage is 3.340. The R load is 2. So the peak voltage is 100. The power switch is 160 Celsius. Peak to find the Imax, we peak over resistor. So 100 divided by 2 is 50 ampere for each diode. Power max is I square over R, 50 power 2 over times 2 is 5 kilo, and then the I V over R is 340 divided by 2 is 170 ampere. The current max for this circuit is 170 ampere. Use 4 diodes in a parallel, a diode in the circuit. Okay, so these are the circuit. So this one they call as R load. So the supply, power supply, one diode, and then the resistor. This indicates the half wave rectifier. So now the flow of the current is like going to like this. When we changed it to like this means it shows zero. So my result is like this. For the V in, for the V in, my result will be like this. So 0 to 20 volt, and then for the one cycle, like until here over here, for the 1 millisecond, and then the output voltage will be like this. So it's called half wave rectifier because this is only for the positive cycle, and then the negative cycle will be zero, and then it go to the first level positive, and then the negative will be zero for the half cycle for the first single diode. That call is R load for the only R resistor. So for the second one, for the second diode, mm, Okay, this is called as RL load because of resistor and inductors. This is also half wave rectifier because one diode. So simulate. So I will get the output is like this because of this one is resistor value, and then this one will be the inductance because it cannot be suddenly discharged. So the result will be discharged little bit until some value, and then it will be strike until the zero for the half wave rectifier. And then okay, this one they call a RL wheeling diode. So this circuit will be like mm, the output will be like this one ripple slow, and this is called also a wave cycle, and then the result will be like this, and then this call is inductance because of this inductance need to be charged and discharged, and then uh, the design circuit like this. Thank you.